Hello, everyone. Welcome. Welcome to the session today. Thank you all for coming. People at home watching through Salesforce Plus as well, very welcome. With so much great content these 2 days, it's very appreciated you chose and come and see mine. As with all sessions, I'd like to share a forward-looking statement. As we're a public traded company, please only make purchasing decisions on any functionality that is currently available, just in case I mentioned something that might be coming in the future. So again, big thank you to everyone. My name is Justus Vandenberg. I am a technical architect in the UK and Ireland team, specializing in everything related to the Salesforce One platform, but everything related to integration on the Salesforce One platform. And I've worked over a decade in heavily regulated industries, and with all the challenges that come with that. And one of those challenges led to my talk today. So, to the good part, why are we all here? We're talking about ingesting data into Data Cloud. Data Cloud is a fantastic tool, and with that tool, we can ingest a lot of Salesforce data, not only accounts and contacts, but all sorts of Salesforce data. We can ingest that into Data Cloud, generate that in all sorts of actions. Now, the way how we get that data in Data Cloud is by pulling that data using the CRM connector that is out of the box with Data Cloud. So today what I'm going to present is an alternative approach where we're not going to pull that data, but we're going to push the data from any Salesforce org, any data from any Salesforce org into and from any Salesforce org into any Data Cloud instance. Now, the advantage of being able to push the data is that you are able to fully control what you send, and the data that you are sending is actually controlled. We have the sharing rules and visibility applied, because one of the main issues that we have with the CRM connector is that it requires the view all data permissions. Now, the issue with the view all data permission is that if you want to import any data into your Data Cloud org, that all accounts come in at the same time. So say we have a regulated environment where we have, say, business accounts, retail accounts, but also investment accounts that are all completely separated brands on the same org. They have their own data governance, their own processes. They have everything completely separate. And only the retail accounts would be to be in Data Cloud. If you have the CRM connector, all data would come in at exactly the same time. And there are some filter options, but it might not always be enough to have all those filter options available. So for a lot of regulated companies, the true issue is that the view all permission might not even be allowed at all. And that's what we run into. So to circumvent that, we need an alternative approach. So what is our solution? The alternative solution is to call the Data Cloud Ingestion API directly from your Salesforce org and ingest that data using that way. And the solution is twofold. On the one hand, we have a custom auth provider that we need to connect to the native Data Cloud APIs, which we use with a named credential. So we stick to all Salesforce security best practices. And on the other hand, in order to call these APIs of the ingestion API, I created a Data Cloud Apex library, which contains Apex methods for all the ingestion API options. On top of that, I created a UI, sort of admin-friendly UI, so you can load data or upload data CSVs, etc., and test your application directly from your Salesforce environment. Now, there's different ways to interact with Data Cloud in general. So first, we have a remote org. This means in a remote org, your Data Cloud is activated on a different org than the org you're calling Data Cloud from. And if you're on the home org, it means that you're calling Data Cloud from the same org as your Data Cloud is enabled on. So ways to connect are, when we're talking about the remote org, we have the native Data Cloud API. In the native Data Cloud API, we can use that for queries, metadata, unified profiles, you name it. And to insert the data, that's what we're looking at today, we have the streaming ingestion API and the bulk ingestion API. Salesforce made our life a bit easier, so they created the Data Cloud Connect REST API, which is a Salesforce REST API, which is a layer on top of the native Data Cloud APIs. So you can use your standard Salesforce integration, standard OAuth flows to get exactly to those APIs. If you're on the home org, you have another couple of options. So we have a number of Apex classes in the Connect API namespace, which we can use to get data from Data Cloud. And we have the option in Flow. We have a Flow action, which is called send data to Data Cloud if you want to stream records. Now, the problem we have here is that we have the streaming ingestion and the bulk ingestion are not available in the Data Cloud Connect REST API. And that means we have to connect directly to the native Data Cloud API. So that's a bit of the reasoning behind it. So if we put this in a simple flowchart, if we want to interact with Data Cloud, and it's installed on the home org, we want to ingest data, then at that point, we need to use, if we want to stream, we can use flow actions. If it's bulk, what we need is the Data Cloud API. If we want to interact on the home org, we want to retrieve any type of data, we can use the Connect API REST Apex classes. Now say it's enabled on a home or on a remote org. If we want to ingest data, both streaming and bulk are required to use the Data Cloud API. If we want to retrieve data from a remote org, what we want to do is use the Salesforce Data Cloud Connect REST APIs. So, quick step back just to say how an OAuth flow works from a Salesforce to Salesforce connection. So on the right, we have the connected app with the Salesforce OAuth scope that defines what they need to do. Then we have a named credential. On the named credential, they will request the Salesforce OAuth token. The Salesforce OAuth token, everything is all right. It will be connected. And now we can connect Apex through an Apex method. We can do an invocable method if we want to use Apex through flows. And this is an out-of-the-box OAuth flow that we can use, something like a job bearer. So we do not have to do anything. Now, when it comes to the native Data Cloud API, we get a few extra steps. So once we have done our token exchange, we need to do a second token exchange to get a Data Cloud token. So what we have is we have the Salesforce Access token, and then we exchange that Salesforce Access token for a Data Cloud Access token. Now, that cannot be done because basically we're joining two flows into one, and that cannot be done out of the box because it's highly specific. So we need to build a custom auth provider that can take care of that, and then we can use the named credential to talk to the auth provider, and we stick to the security standards by using named credentials, and we don't have to worry about any token, storage, etc., all taken care of. So now we can connect. Oh, sorry. We have the auth provider configuration. So setting up the custom auth provider is really easy to do. All we need to do is we give it a name, we select our plugin, and we give our connected app ID. Optionally, we set some error logging or some login history. We give our integration username, so the one user that's authorized to use this integration, and signing certificate, and the My Domain URL. As soon as we have this, we can easily connect and do that token exchange. I will share the code at the end. I've made a resources slide that we can look into. Everything is completely open source. You can look at it at your own pace. But the gist of it is that we have a CDP grant with a subject token that is a session ID, and we're going to send that to the token endpoint of Data Cloud, which is the A360/token endpoint. Now, quick comparison between what a REST API looks like, a REST API endpoint looks like, and what the native Data Cloud API endpoint looks like. On the REST API endpoint, we have a My Domain URL, and then we have the services data API version, and then the single source of truth, and then whatever API we want to call. On the native Data Cloud API endpoint, we have our Data Cloud org hash, then we have the C360 endpoint, API version, and then the API. So in this case, I was talking about the ingestion API. Then we select the source, and then we select exactly what is the connector name of your ingestion API, and what object in the ingestion API are we going to call. So now we can connect. The next step is to be able to use an Apex library to call all the different Apex methods, or to call all the different ingestion API endpoints. So the first thing we need to do is to set up a metadata configuration record, and in this record we are able to tell Apex exactly how to connect. So we set up a record name. This is what we're going to need from Apex to specify what we'll need. The Salesforce named credential is more for future, so we can ignore that for now. We have a Data Cloud named credential, which is the named credential to our Data Cloud instance. We have an object name for Salesforce object because the whole idea is to be able to map a Salesforce object to a Data Cloud object. It's completely optional. The mapping is not mandatory for it to work, but it is handy, and I will show you in a little bit. We have the connector name and the target object, and these are the values that I just showed you in the endpoint URL, and these are the values that we need to populate to tell our Apex classes to where to go and which to use. Lastly, we have our data lake object name, and our data lake object name is mainly used for being able to test or generate test data and a test data template, and I will show that in a little bit as well. So the second thing we need to do is set up a mapping, and the mapping is on your left hand we have the Salesforce fields, then we have in the middle the target fields, and we select on the right a Data Cloud field type. And based on this mapping, we can map what a Salesforce object looks like in Data Cloud and which field type comes with it. And based on that, we can generate some templating. So the format of the streaming ingestion API is literally a piece of JSON with a list of, with a data array with a key value pair, a set of key value pairs for each record. So all our ingestion Apex library does is just translate the Salesforce record to this data format. The utility has a number of methods. I won't go into too much detail, but you can look at that at your own pace. But we have the utility, the Data Cloud class, then we have a method that is called stream records to Data Cloud asynchronously. We specify our metadata name, so based on the metadata, we know exactly what to do and where it needs to go. Then, because it's asynchronously, we can only have primary data types, so we put in the serialized records. This is ideal for, say, platform events. If we want to stream records, Salesforce records, just as object records, directly, so completely synchronously, we can use this method. And then based on the mapping I just showed you, based on that mapping, everything is done automatically translated to the right headers in the CSV file. We can also do this with just a list of object maps. So if you have an Apex data structure, not specifically an S object, we can use that method. And if you want to go fully rogue, you can just completely build your own payload as well, if that's what you're interested in. And we have a test flag, so we can test our payload format. For the bulk API, we have a number of different methods. So we have a create ingestion bulk job. We can either create an upsert or a deletion job. And once we have that job created, we get a job ID. And once we have the job ID, we need to add CSV data to that job. So we can add some CSV data. Once we have this all CSV data added in our bulk job, what we do is we can either abort the job or we can complete the job. Complete is normal. And optionally, you can delete a job as well if it wasn't necessary. So I'm going to show you a little demo because I built a UI on top of all these methods. So we have a UI for the bulk ingestion, a UI for streaming the records, and for testing. And we have a tool to query Data Cloud and a YAML generator to create a YAML file to make life a little bit easier when we are setting up. So first thing is, resolution is a bit, that should be better, yeah. So the first thing is we have an application which is called the Data Cloud utility. And then we have a Data Cloud ingestion, bulk ingestion object. Unfortunately, we can't see the title. But what we do is we select a metadata configuration. What I've done here is we have smart billing, smart device events, smart readings in a demo. So say I would select my connector for smart billing. Then this will give me all the jobs in the ingestion API, all the bulk jobs for this specific object. Now, if I want to create a new job, what I can do is just create an upsert job. A new job is now being created. I can also create a delete job, because deleting data is always an interesting one in Data Cloud. And what I can do now is I have the action drop-down. I can add CSV data. I can upload CSV files, or I can complete the job. So basically, all the methods I've just shown are just now here in a nice visual interface. So say I'm going to add some CSV data. What we have here, it will automatically generate some sample data with the correct headers that Data Cloud accepts based on your mapping. So now you know, as an admin, you can say, oh, this is what my data should look like, and we can add that data. We can also upload a CSV file. I don't have anything ready, but if we have an upload CSV file, it's literally as simple as pressing the button here. And that's all there is. We can then go to the streaming ingestion utility. And again, what we select here is we can select our smart billing object, and it will automatically generate you a payload based on the mapping. And we can send this payload directly to Data Cloud, we can stream that directly, or we can test it. Now, if we test it, it goes synchronously and it just validates that all data you have is the way and the format it should be. So this is ideal for testing. So say we have the amount, and this should be a number and not a string. If we now test this, and this would be wrong, we get an error message where we say, oh, the amount is expected a number, but we actually found a string. So it will tell you easily if your payload is wrong, which is perfect for testing. Next thing we have is a Data Cloud query utility. And in the utility, this is literally the same as Data Explorer. But what we can select here is it will automatically generate you a query based on the mapping and based on the data lake object you've selected. So now you're able to just quickly check your query, quickly update your query, and now you have all the data nicely in here. Now the advantage of this is that you can also do a CSV export. And now we can query all the data in a CSV format, which is a lot more records for everybody who's paying attention. So something's not going right. And this will have you the correct headers. And now you can export this to a CSV file. So say if you would want to delete this, we can simply just download the CSV file, and we can upload the CSV file as a deletion job. And it has the correct headers, everything completely ready for use. Last, but not least, let's go to the pre-one, is I've created a tool to generate a YAML from a Salesforce object. So if you create an ingestion API, you need to set it up based on a YAML file format. I've just created an object where you select an object you have in Salesforce, you select which fields you need, and all you need to do is just press the create YAML file, and you have a YAML file that is 100% ready to start using in Data Cloud. So all you need to do is download the file, upload your YAML file, and you're ready to go. So it's just a handy tool, especially if you want to do things like platform events with one-to-one mappings, or just to see an example of what it should look like. So that, in a nutshell, is the application. Seen it in action. So what I showed you is a UI implementation of the different Apex library methods. I've showed you an alternative solution to the CRM connector that comes natively with Data Cloud, which you would only need if you want to stream org data to a remote Data Cloud instance, or you cannot use the read-all permission on any of your objects. So there should be absolutely at least no technical constraints or any barriers to ingest your Salesforce data. Now, there's a few considerations because we are a technical audience, so I have to name them. We are stuck with the Salesforce governor limits. So we have mainly the API limits we need to worry about, or the API size limits, because there's no call-out limit from Apex per se, but the call-out size you can do does apply. Data Cloud credits, just need to mention it, they are based on rows processed, so always check with your implementation provider before you implement anything, just to make sure you know what you're doing. And from your development team perspective, you have to maintain a library, and you're following a non-standard architectural pattern. So that's not a bad thing. It's just something to keep in mind to know what you're doing in the future. So I have a moment to share some resources. So in these resources, what I've done is just create a step-by-step manual with all the links and everything you need to set this all up yourself. This will be shared later on as well. And then I would like to thank you all again for visiting. I know it was a lot in 20 minutes, but it's a big and interesting subject or subjects. So again, a big thank you for coming today. And if you have any questions, I'll be around. I'll be this afternoon at the backup booth as well, if you can't find me earlier. So thanks again. And if you have some more time, please fill in the survey. It would be greatly appreciated. Thank you.